Hello there, Mr. Sutton here, bringing you the IM23 Honors 310 homework solutions on arc length and sector area. For number one, we're given the radius of a circle and a central angle, and we want to know the length of arc AB. Well, to find this arc length, we need to know the whole circumference of the circle. So let's start with a 2 pi r for the circumference. That's 2 pi times 14, which we'll just simplify to 28 pi for now. And now we can set up a proportion. We have the whole circumference of the circle. We can put this arc length as the part over that in a fraction. And then we can do part over whole for the angles as well. So we can write 120 over 360 equals the length that we're looking for over 28 pi. So doing a little cross multiplying here, we actually don't really need to cross multiply. If we just multiply by 28 pi, that'll take care of it. 120 times 28 is going to give us 3,360, so we can write 3360 pi over 360. Eventually, though, we've got to divide this. So let's multiply that thing that we just got by pi, and then let's divide it by 360, which gives us an answer of 29.32, and that'll be in centimeters. For number two, we're trying to find the length of arc AB right here, and we are given the central angle for that arc and the diameter of the circle. So for this one, we need to find the circumference, and then we can do part over whole equals part over whole for circle arc lengths here. So for the circumference, normally we do 2 pi r, but because we have the diameter here, we can just do pi times the diameter, which would give us 8 pi. All right, so we have the arc length that we're looking for over 8 pi equals 45 over 360. And then to find that length, we can just multiply both sides by 8 pi. That'll give us, let me see here, 360 pi over 360. So that means that the length that we're looking for is just pi, or 3.14 if we round it off. And that's going to be in feet. On number three, we're trying to find the arc length of arc QRS. That's this major arc out here. So for this one, we need the circumference first, so we can do part over whole. So circumference, that'll be 2 pi r. And they gave us the radius of 8, so 2 pi times 8, or 16 pi. So now we can set up a proportion. Well, actually, before we do that, we need the angle measures here. So they didn't give us the measure of arc QRS. They didn't give us the angle. They gave us 60 degrees for this minor arc here. So QRS, the arc itself, is going to have a measure of 360 minus 60, which is 300 degrees. Now we can set up our proportion. We can say that the arc we're looking for over 16 pi, the circumference, equals 360 degrees over 300, or 300 degrees over 360 degrees. And if we just multiply both sides by 16 pi, that'll take care of it. So that's going to be, let's see, 4,800 pi over 360 on the left side. And then let's divide that on the calculator. So dividing that out, it's going to come out to about 41.89, and that's going to be feet. For number four, they want us to find the measure of minor arc AB, and we know it's a minor arc because there's only 2 letters in there. So we want to find this measure here. We are given the arc length, and we are given the radius. So we're going to set up a proportion. If we do the arc length over the whole circumference of the circle, that same proportion should let us work with 360 degrees and find the portion of that 360 that's taken up by this arc here. So let's do 2 pi r for circumference, 2 pi times 10 then, so 20 pi. So we can say 8.73 over 20 pi equals, well, the arc length, the arc measure we're looking for over 360. All right, cross multiplying, or actually just multiplying by 360 on both sides. We have 8.73 times 360 up here. That comes out to 3,142.8. We're now going to divide that by 20 pi. So I'll just do answer divided by 20 pi. Now when you do this, you have to be extra careful. If you're dividing by 2 things that are being multiplied together, PEMDAS requires you to put those two things in a parentheses like I'm doing here. So we'll do parentheses 20 pi, close the parentheses. If you don't do this, then you're going to divide by 20, but then you're going to multiply that result by pi. You want this multiplication to happen first before the division. So using our parentheses, we get about 50.02. That's going to be degrees. So just 50 degrees then if we round off to the nearest degree. For number 5, we want the circumference of this circle. We're given the central angle and the arc length. So we can set up a proportion pretty much right away. We'll do 76 over 360 equals 7.5 over, well, I'll call it C because we're looking for circumference here. Cross multiplying on this one, we have 76C equals whatever 360 times 7.5 is. My calculator is saying that that is 2,700, and I will take the calculator's word for that. So now we just have to divide 2,700 by 76. Doing that up here in my calculator, that comes out to about 35.53, and they didn't give us units here, so that's how we're going to leave it. For number 6, we want to find the area of sector ED, so that's this red sector here. So for that, we will need the whole area of the circle, and then we'll set up a proportion with the 60-degree angle they gave us. So we'll do pi r squared for area, and then that's going to be pi times the radius 10 squared, so 100 pi. So we can then say that the sector we're looking for over 100 pi equals 60 over 360. If we multiply by 100 pi, we can isolate that area. So that will be 6,000 pi over 360. And let's divide that on the calculator now. Dividing that out, we're going to get about 52.36, and that's going to be square inches. For this one, we want to find the area of sector DGE. So we're talking about this blue sector area here. To do that, we need the area of the whole circle, and we also need to know the measure of this arc. Let's start with the area. That's going to be pi r squared, which in this case is pi times 28 squared. 28 squared comes out to 784, and I'll just keep pi around here for now. Next, we need the angle, or the measure of this arc. So that's going to be 360 minus the 137 that they gave us for the minor arc, which comes out to, let's see, that's 223 degrees. So we can write the sector we're looking for divided by that whole area of 784 pi equals the 223 arc divided by that whole degrees of 360. If we multiply both sides by 784 pi, that'll isolate the area. 223 times 784 comes out to this very large number, and we'll still have a pi after that. Let's divide that by 360 now. So I'm doing 174,832 pi divided by 360 on the calculator. Comes out to 1,525.70 if you round off, and that's going to be square meters. For number 8, we want to find the area of this whole circle M, and we are given this minor arc, or this central angle for a minor arc, and the area of this smaller sector here. So let's set up a proportion. We can say that this smaller area, 38.51, divided by the whole area of the circle, is the same ratio as 165 over 360. Let's cross multiply. We've got 165 times the area that we want equals whatever 360 times 38.51 is. Doing that on our calculator, that comes out to 13,863.6. So we just have to divide this crazy number by 165 and we'll have our area. Doing that out on the calculator, I'm going to get an answer of 84.02, and that's going to be in square meters. For number 9, we're given this smaller central angle and the larger sector's area. We want the area of the entire circle. So for this one, we'll set up a proportion. We have the part of the area, 56.87, over the area of the whole circle, equaling, well, this arc is going to be 310 over 360. Again, they didn't give you the angle that went with the area. You had to subtract from 360 to clear up that little mismatch. Cross multiplying now, we've got 360 times 56.87 equaling 310 times that area. Multiplying out 360 by 56.87, I get 20,473.2. Let's go ahead now and divide that by 310. And that's going to give me a circle area of 66.04, and that'll be square centimeters. For number 10, we're given the area of this entire circle. They also gave us the area of sector KL, that's this smaller area here. They want us to find the measure of arc KL. So we can set up a part-whole proportion. We have the part of the area, 42, over the whole area of 260.67, equaling the arc measure that we want over 360. If we multiply by 360 and then divide, that'll give us our measure. So 360 times 42 comes out to 15,120. And let's go ahead and divide that by 260.67 now. Letting the calculator do that division for us, we come up with 58 approximately, so we'll call that 58 degrees. For this tricky problem number 11 here, we're given that distance RS is 12. We've got these two semicircles, and we're trying to find the total distance that these two semicircles make up. The key on this one is realizing that you're basically adding two half circumferences together. They're not necessarily the same size, but they're definitely half circumferences. So in general terms, we can write that the length we want is half the circumference of circle R plus half the circumference of circle S. Now, circumference, we can be a little bit more specific. That's 2 pi r. So instead of circumference of r, we can write 2 pi times the radius of r. And over here, we can write 2 pi times the radius of s. Now, you might think, well, we've just made things worse. This looks nicer than this stuff down here. But look what we can do here now. 1/2 times 2, those are going to cancel out. So we can just write pi times the radius of r plus pi times the radius of s. And at this point, if you actually knew the radius of r and the radius of s, you could solve this problem. We don't know those individual radii, but we do know what they add up to. So one more little sneaky thing we can do here, these both have a common factor of pi. What happens if we factor pi out? Well, then we get pi times parentheses radius of r plus radius of s. We know what the radius of r plus the radius of s adds up to. It's this distance rs that they gave us right here. They said it was 12. So this is just pi times 12, which is, of course, 12 pi. Choice C. For number 12, we have point O, which is the center of two circles, and we're also told the circumference of the larger circle is 36, and the radius of the smaller circle is half the radius of the larger circle. Based off of this, we want the length of this darkened arc in here. All right, so how do we get started on this? Well, ultimately, we can find the length of this arc if we can set up one of those part versus whole proportions using the circumference of the inner circle. So we need to find that inner circumference first. Well, the key on this one, we know that the radius of the inner circle is half the radius of the outer circle, so the circumference is also going to be half. So then half of 36 gives us 18 for that smaller circumference. And we're looking for, I'll just call this darkened arc here x, so I can refer to it in an equation. So I can then write x, the part, over the whole, 18, equals the part angle, 80, over the whole angle, 360. Not sure if this was a calculator question or not, but we don't need a calculator. You can reduce 80 over 360 by 40s. That reduces to 2/9. Cross multiplying, we've got 9x equals 36. So then x equals 4. Choice D. For number 13, if the minute hand of a clock moves 45 degrees, how many minutes of time have passed? So this is one of those part versus whole sort of problems. We have 45 degrees out of 360, and we want to know how many minutes out of 60 have passed based off of that. So we can set up this proportion and then cross multiply. Before we cross multiply, though, we can actually reduce this 45 over 360. That's really going to be 1 over 8, if you divide by 45s. Cross multiplying now, we've got 8m equals 60. And dividing 60 by 8, well, that's going to be, let's see, this is halfway between 56 and 64. So dividing by 8, we're going to get 7.5 then. So 7.5 minutes have passed. Choice B.